essentially what we're doing is we are, we're not systems integrators anymore. And when you say you're a systems integrator, you're basically saying I do level 0, level 1, and a little bit of level 2, right? I do automation, I do HMI SCADA, and that's it, right? That's what a systems integrator is. We use Industry 4.0 principles to digitally transform plants into digital factories. That's what we actually do, right? That's the business we are in. A subset of that is systems integration, right? But sometimes we're not integrating a system. Sometimes we're creating systems. And that's fundamentally the difference between the systems integrators of old and the systems integrators today, right? So if you are a software or hardware provider that we're going to buy from, so either we're going to buy from or one of our end users is going to buy from, and you are not making your software available for download on your website without ever having to talk to a person, and without it being able to run for a couple of hours, fully licensed, and reset it, the similar, we're talking about the way KEP server does it. We're talking about the way inductive automation does it. If you are not doing that, you are going in the wrong direction, right? You are going in the wrong direction. If you are using unified architectures, if you want to own the whole stack, if you are developing proprietary protocols and you are not going open architecture, you are going in the wrong direction. You're going to be dying. You're not growing. These are simple concepts. They're not difficult. It's not hard. Doesn't matter who you talk to. They all agree. You talk to any integrator, you talk to any developer, you talk to any end user. They're all asking for exactly the same things. The only people who disagree with you, the ones, the legacy companies who develop that software. They're the only ones. It's their engineering guy who's going to tell you, no, you're wrong. Mqtt is not a protocol of the future. Okay, buddy. Well, I'm sorry you feel that way, but you're definitely wrong, and I've got the money to prove it. And I have the client base to prove it. This is what we were talking about earlier, that it's important. It's important that hardware and software manufacturers in the space understand this. It's really, really critical, because it's not us who's driving IIoT and digital transformation for our customers. It's the customers who are driving it for us. Our company is in the image of our clients' requests. That's what it is. So to answer your question, what is it we do, when you were asking, what do I tell people we do? That's it, man. We use Industry 4.0 principles and IIoT to digitally transform plants into digital factories. That's what we're doing.
Amazing.
All right, cool. Let's talk about our development plan for next month, right? Or for actually this month, the 2nd. So I put together this idea, and this is all in it's fluid. So you provide feedback, and we'll decide how we want to build this. But again, the concept here is that you and I are going to develop basically 4 hours this month each. So it's going to be 8 hours altogether of engineering. We're going to do it in 1 hour segments, and we're going to start with a functional design and scope of work. And you and I are going to build. And actually, I'm thinking we'll get our other developers involved. So maybe you don't just shoot with me. Maybe you'll work with other developers inside with Intellic. And we are going to do 4 1-hour sessions where you develop and someone from Intellic develops. We're going to film the whole thing. You're going to break it into smaller videos, but we'll make the full videos available. And we're going to build a solution that we're going to make available to people. They can come and access it in the cloud. And so what I've started is kind of my concept. So we're going to have a cloud server that's going to have Ignition controller, full Ignition Pro running on it. And that'll be our controller. We'll use SQL Server Express. We're going to add Chirp by Canary Labs for our historian, and that's going to run on that cloud server. So this is going to manage our global SCADA. It'll be our EAM controller, our Mqtt broker. It'll have our database. We'll have our Canary Labs Chirp historian, which is the Ignition version of the Canary Labs historian. We'll do all of our global project management here. So we're going to do all of our development here and then publish using EAM to our agent. The Ignition modules we'll use Ignition Pro. we'll use EAM, web browser, Cirrus Links, Mqtt, distributor transmission engine. We'll use Ignition's web dev. We'll use 4.0 Solutions RTF module. So this is it basically allows you to open rich text files inside of Ignition, and you can edit them and all that kind of stuff. And then we're going to use the 4.0 Solutions Chirp module, right? Additional software will have the Chirp Historian from Canary Labs and SQL Express running on that cloud server. Then we'll have another cloud server, which is going to run Ignition Edge. Originally, I had just regular Ignition on here, but I decided, you know what? I want us to show the strength of Ignition Edge, but also what is its limitations. What are the types of applications you want to be using Ignition Edge on, and what type of applications do you want to be running full-blown Ignition on? Since inductive automation changed, they got rid of the tag limitation. So it used to be Ignition Edge was limited to 500 tags. They've removed that. So now there's no tag limit. We're going to go ahead and use Ignition Edge and another cloud server. These will be connected over the gateway area network using the EAM module. We'll have KEP Server EX running on this external machine, or the agent, and we'll have SQL Server Express running. So now the Ignition Edge people will say, well, you can't talk to a database. Yeah, you're right. KEP Server is going to talk to the database. We're going to use the data logger from the data logger plugin from KEP Server EX, and I'm going to show you how you can we're going to show you how you can build a local historian using just Kepware. So without having to use anything else. So Kepware has a local historian plugin, which puts your data into basically flat files that they consume, and then you can use like a HDA compliant client, an HDA client, to consume those files. But one of the best way to build like a local historian is to use Kepware's data logger, because then it stores the data into any database, and so we'll store it into SQL Express, and then we can use Ignition to consume that, right? So you think of it as like data logger equals transaction group in Ignition, kind of like that, right? Okay. So this remote server is going to have our local HMI, our EAM agent. We'll have Mqtt transmission running here. We'll have a KEP server simulator running in KEP server EX. The data logger will use the KEP server IoT gateway, because we're going to publish back to this broker here. The Ignition modules will have Ignition Edge, EAM, engine, transmission, and software will be KEP server EX and SQL Express. So a couple of things that I was thinking, we would do Hive. So we would do Hive MQ, this broker. I want to take some public Mqtt brokers that are out here, and we want them to publish back to our broker.
Okay.
So other public brokers. And we'll have them publish back. Okay.
I have a question.
Yeah.
In layman's terms, what's the difference between the Mqtt engine, the transmission module, and the distributor module?
It's a good question, dude. All right. So Mqtt engine, it basically what Mqtt engine does is it can turn topics in a broker into tags. That's what engine does. So an Mqtt topic can look something like this. It can root / temperature / temp1, right? That can be a topic. And the payload could be a value of 100, right? So what that would do, what Mqtt engine does, is it turns that topic into a directory called root with another directory called temperatures with a tag called temp1 that has the value of 100.
Okay.
That's what engine does. Okay.
So it's not even really an Mqtt thing. It's just once the values get to the broker, it turns them into Ignition tags automatically.
Yes. Now there are different types. So there are different types of payload formats, right? So if we look at MQTT, right? What is MQTT? It is topic and it is payload. So topic is the location and the payload is the value, right? So if I have a tag, if I have this topic, which is root, and I say, I want you to go ahead and in this topic, go to this broker, go to broker 1 and publish to this topic that payload, this value of 100. And actually this would be a string. If I'm using just regular MQTT, flat MQTT, what I'm going to end up with is this topic with a string value of 100. But if I use something like, say, Sparkplug B, the Sparkplug B specification, this payload doesn't contain just the value. It contains all of the information that your engine would need to turn that into tags that have data types and all that kind of stuff. So by default, if you use just generic MQTT, your payload's always a string. So you could pass a value of 100, but it doesn't have a data type associated with it, right? That's the limitation. And believe me, we have these conversations with our clients all the time, or even hardware manufacturers. We're trying to explain to them the value, the reason you need to adopt a specification. So part of the reason that Eclipse now manages Sparkplug is because people who are hardware manufacturers who are supporting MQTT, they need to be formatting their data, just like with, whether you're using OPC UA or OPC DA, you need to format the data in a way where it can be deciphered on the other end. And so Sparkplug B is the specification that tells you how to format these payloads so that you can then generate tags that have data types and metadata and attributes and all that kind of stuff, right? So
what's interesting is that I heard from both Vikram at Easy Automation and Kyle Anderson at Maple Systems that you were the major proponent of getting them to adopt the Sparkplug B and working well with Ignition into their hardware.
Really?
Yeah.
Yeah. I spent a lot of time. So we'll talk about the Easy Automation and Maple. So Kyle Anderson, great guy, love him to death, love working with him. He's awesome. I'm not the easiest guy in the world. Me, I'm so focused on the solution. Our whole company, we're like that. We're focused on solutions. I'm so focused on the solution that oftentimes I don't think about people's feelings when I'm going. Actually, I never think about people's feelings. That's one of my limitations. But the Easy Automation, Vikram was already, I think Vikram was already on board. He was at ICC last year. He talked to Arlen himself. He was already on board to adopt Sparkplug B, I think. I just pushed him over the edge. I contacted him right afterwards. I bought one of his PLCs. I loved them. I thought they were awesome from the beginning. I did that whole demo last year. The first demo that we did, they didn't support Sparkplug B. So I was able to show what does the data look like when you bring it in. If you go on our YouTube channel, you can see that video. What does the payload look like? Now, if you look at it, the payload looks completely different. And now the tags that are inside of the EasyLogix PLC, they get published directly into the Ignition broker. But even if you use the Chariot Scada broker that CirrusLink makes, it's the same thing. They come in as tags with data types and metadata and attributes. It's important. Adopting that specification is important. Maple was slower to respond because Kyle didn't have complete control over whether or not that solution got done. Vikram is the president of Easy Automation, so he could just make the decision. Kyle had to make the case internally, but they did. They were one of the first companies. I mean, now there's I don't know, Arlen have to say, but there's more than 100 manufacturers who have adopted the specification. Hilscher and Mqtt and Opto22. And I mean, there's a long list of people who've adopted it. So, but yes, I spent a lot of time making the case for it. And here's another interesting fact. They're not the only two. There's probably a dozen companies that we've been directly involved with to get them to adopt Sparkplug B for their MQTT formatting. Now, mind you, Ignition doesn't need Sparkplug B. It can talk Sparkplug A. It can talk something like 9 or 10 different formats of MQTT payloads, including just a flat payload, which is what KEP server publishes. So KEPware, the IoT gateway inside a KEP server, it just publishes a flat Payload. It basically grabs all the tags you're requesting and builds a JSON and just drops in the dictionaries of the tags, right? Ignition talks that. If you publish it in, it'll come in and all those tags, and then you just got to write a parser that can turn that JSON into tags, right? You can write the create tag method from the system API, right?
Yeah.
But we Kepware is another company that we talked to about adopting Sparkplug-B. I think they'll come around. They haven't yet, but I think they will, because Sparkplug-B is the specification that all manufacturers are using. There isn't a competing one out there. But the guy who invented the protocol wrote the specification. So it's like,
what's interesting is, Kepware now owned by PTC.
Yeah.
They have a heavy partnership with Rockwell. I noticed that they announced that at like the IoT things, and also Microsoft. But so it'd be interesting to see like what Rockwell does with their IoT vision. And
so, so right, I was at Automation Fair last year, so in Houston. So I go and I go meet with they had one IIoT session at Automation Fair, and they were announcing that they were going to be supporting IIoT protocols. They didn't say Mqtt. So I ended up going to the product manager and after the session and saying, hey, what is the plan with Mqtt? And they said, oh, it's kind of under the radar. We are supporting it. It's going to be in this one gateway we have called the EN900. It's a little like industrial router where you'll be able to convert tags into Mqtt topics. But here's the problem. They're not supporting any specification, and they're not making it open. They're only going to be publishing to a Rockwell Mqtt broker. At least that's what they told me last year. So they may have changed their mind. I spent a lot of time talking to the Rockwell folks. Are you going to move to open architecture? Are you going to be able to publish? What we really want is an Mqtt client or transmitter inside the Allen Bradley PLCs. That's what you want.
That'd be nice. Yeah.
Because then you could just publish to any broker from the PLC and forget using OPC UA.
Yeah.
If you look at what PTC did, right? PTC's ThingWorks is one of the greatest software platforms I've ever played with, right? It's an amazing platform, incredibly powerful, beautiful, slick, fast. You could build your own SPC engine inside of ThingWorks. Couple problems, right? You can't download ThingWorks just on their website. You can't just download it and try it, right? Training people it takes a while to get people trained on the platform. PTC did not have any communications protocols, right? Kepware owns all the protocols. They own all the drivers. So it was a natural marriage for PTC to buy Kepware because Kepware's got all the best drivers. So now PTC needed the connectivity to get to the edge, and so they bought Kepware. And so now their plan is to take Kepware, take the PTC ThingWorks solution and manufacturing apps and all that stuff, and move that to the edge. They want a I don't want to say unified because they use an open architecture strategy, but they do want a unified solution. They do want a complete stack where they can provide solutions at any layer of automation, right? That's the reason that they did that acquisition, right? All right, so let me. So the difference between engine, transmission, and distributor.
Yeah. So that's the engine.
Yeah, engine creates your tags. Transmission allows me to take tags and say, I want you to take everything that's in this folder, and I want you to publish it to another broker. So anytime a value changes, I want you to monitor for that change, and I want you to publish it to another location using Mqtt. That's what transmitter does. Distributor is the broker. So they don't, rather than call it Cirrus Link broker, they call it Cirrus Link distributor. Distributor's job is distributor is essentially the gateway, the Mqtt gateway. All of your Mqtt clients out in the field, they publish to one distributor, one broker, or several brokers, but they publish to a central broker. The broker is where people who want to consume that data, they talk to that broker and they say, I want to subscribe to this topic or these list of topics. The distributor, the broker, is what keeps track of the people who are subscribing, and it sends them the updates when the values change. Also, it keeps track of all the topics and whether or not they have been their birth and death certificates. And if you understand the way MQTT works, the broker is the one that keeps track of all the stateful connections to all your telemetry in the field, and then it stores all the topics and values, and then it keeps a track of everyone who's subscribing to them, and lets them know, hey, something changed.
So they all kind of work together.
They do. You don't always need them. You'll notice Ignition Edge out here. We do want engine because we want to have MQTT tags on the edge, and we do have transmission, but we don't have distributor because we don't need a broker out here. This is our broker up here, right? So, and in many cases with Ignition Edge, you don't even use engine. You just use transmitter, and then you point the transmitter to, like, say, the default tag provider, and you tell the default tag, you tell transmission, publish any changes in the default tag provider back to this broker.
So we're using the engine at the edge, the agent edge gateway, because that's going to connect to the IoT things, the IoT server.
So the reason we're using engine is because we're going to end up, so on the edge, we're going to have a default tag provider, right? So for the Ignition developers out there, we're going to have a default tag provider. And let's say we're going to have a, that's weird. Oh, I didn't put a space. That's why it didn't work. There we go. So let's say you have a default tag provider. We'll have a folder called rigs, and we'll have inside there, we'll have rig 1 and then tag 1, right? We will also have a tag provider called MQTT Engine. Now, MQTT Engine is the tag provider that's created when you install this module, right? Now, let's say that we have multiple instances of Ignition Edge, and the only tags that are on this instance are rig 1. But I have another rig that is rig 2 on a different instance. I have 2 instances, and they're both publishing back to this broker. But let's say I want to see the tags for all my rigs. I could do this. I could have rig 2 in here, or rig 1 and rig 2. And I could have tag 1, and I could have tag 1. So at the edge, I would have this. I would have default rigs, rig 1, tag 1, and then my transmitter would publish these tags back to the broker. Then my engine would connect to the broker, and it would say, send me all, I want to subscribe to everything that's in the rigs directory. So my central broker has all of the tags from all of our different nodes. But on the edge, the only tags that exist in the default directory are for me, and everything that and all my tags exist in the MQTT Engine directory. It gives me the ability to essentially, this is the whole concept of IIoT, right? I don't have to build a custom application to have the values of my entire fleet available at every node. I just use an IIoT protocol like MQTT. All I do is say, listen, send me everything that's in the rigs directory. So my Ignition OPCUA default tag provider is pointing to one PLC, rig 1, and I've got one tag in there, tag 1. Then my transmission module is publishing all of this back to our namespace. Then the MQTT Engine module is subscribing to the entire namespace. So every rig comes back in the MQTT Engine. You understand the loop? And he disappeared. Do you understand the loop?
Yeah. So then what you would do is, if you were to make any screens on your edge gateway, you would want to reference the MQTT Engine.
That's exactly it.
Space.
Exactly.
So then it's dynamic.
It's fully dynamic. And so you know what this creates? And this is a term I coined: self-aware Scada. So here's what happens. Now I launch a new node. I have a new rig, whatever that is. I launch a new rig. I bring it online. I point it to the broker. And guess what happens? It shows up in my namespace, and I didn't do any engineering whatsoever. I built one application, and it showed up in the namespace. So once I brought rig 3 online, this is what MQTT engine looks like without me doing anything. So now I can go ahead and reference here for my screens. All I do is change rig 1 to rig 2 to rig 3. It's all self-aware.
Okay.
This is the value of IIoT.
You know how there's like internal internal tag providers, and then there's database tag providers?
Yes.
Is there a way to have the MQT engine backed by a database tag provider? So then you could just query the rigs that are in that engine to drive your screens, or like to drive a dropdown, or as opposed to having to do like system.tag.browse tags, which is kind of resource intensive?
Yes. So the answer is you do that. There's a different way we would do that, but the answer is yes. So, so here's what we do. Okay. And we could show this, but we don't generally have our screens look at MQTT engine. That's not what we do. This is actually what we do. We create another tag provider, and we'll call our tag provider Scada. And then what we have is UDTs in here. Okay. So I have a rigs directory, and then I have a UDT instance called rig. And what this does is my tag 1 is an expression tag. It's an expression tag that points to this tag.
Okay.
And then what we do is we have a global script running that checks the MQTT engine, and when this rig 3 shows up, what we do is we generate the new instance for that with that reference automatically. There's a global script that runs, and it says, browse this, look for this. If a rig, for every rig that exists, do we have a sibling UDT instance that's referencing it? That's what we do. And then we just write to the property so that we're not actually using the engine, because our expression tag can do all the exceptions. It can say, if the value's not good or quality's not good, ignore it.
Right.
Put this default value in there.
We could also have other metadata tags or other stuff that wouldn't be in the MQT engine and shouldn't be in there, because that's all auto-generated. So if you wanted to have like a memory tag for some set point or something,
correct,
you could put that.
And here's the other thing. Let's say you restart your engine and you don't have your values persisting, because by default you don't persist values in the engine. Let's say you restarted it. You restarted the module. Well, these tags are going to populate only when the value changes next. So that tag won't even show up till it changes next. Is basically how it works.
Okay.
Yeah. So
I figured there was a good reason to do it that way, but
yeah. So you can basically create self-aware SCADA systems, and that's what we've been doing with IIoT.
Amazing.
Yeah, it's really, really slick. Now you can see why it matters that people adopt Spark Plug B. Because if they don't adopt Spark Plug B, you don't get this format.
Yeah.
You get one tag. So for example, Kepware publishes one topic, and it's like Kepware IoT Gateway. And then the payload is a big, huge JSON with a dictionary for every tag. You have to write a parser that knows how they formatted the JSON so that you can generate your tags. And let's say Maple Systems, before they adopted Spark Plug B, Maple Systems has a flat MQTT, and then they have Spark Plug B specification. The flat MQTT is the same thing. They publish one topic with a big, long JSON and a dictionary of all your tags, and you got to parse them. But guess what? You got to parse them differently than you would with Kepware. So your parser is dependent upon the hardware at the edge, and you got to write it fresh every time. When the hardware manufacturer adopts the specification, then all you do is use CirrusLink's Spark Plug B setting in the MQTT engine, and it knows the format of the JSON, and it parses it for you and generates your tags automatically.
Okay. I'm following.
Okay. Well, you're a smart guy, so I expect you. I expect you to follow. All right. So
yeah.
I don't want to make it. Well, I'm going to go ahead and leave this over here rather than.
No, this is good. Yeah.
So the plan here is like, I don't even know yet, you know, and this is where I'm looking for your feedback. So part of when we do this, there are things we want to highlight, right? Like one of the things I want to highlight is the power of Canary Labs Chirp Historian, right? What's the reason you'd want to use that, right? Why do we want to use that? You know, so, all right. So ultimately the plan is so that the next steps here are, you know, that's a high level overview of what we want to do. So that's a high level overview of what we want to do. The next steps are, I'll put together basically the formal scope of work. And then I'll put together a functional design. And then in our next meeting, I'll go over that with you. So I probably need, let's say Friday. Will you be available to? So
I like the idea of doing the development on Friday.
Okay, cool. So then what we'll do is we'll go through our steps. We'll spin up our development environments. We'll all that stuff on Friday.
Okay.
And then what I'll probably do is already have the servers created and already install SQL Express. We'll install Ignition. We'll do the Ignition installations and our base project all fresh. We have like a default base project we use.
Okay.
And then we'll start with that. All right, cool.